Hey guys, welcome back to the video. So in the last class we have seen about recursion concept. This time we will see about some examples of recursion to understand how exactly it works. So three questions I have brought you. What are the three questions? First one is factorial. So all these are different types of questions, okay? First one is factorial, second type is Fibonacci series, and third is Tower of Hanoi. Okay? So these three examples, let's first understand one by one. So first one, what is first one? It is factorial. How factorial works? How factorial will work? Okay, factorial, if I give you 4, what should be the answer? Answer should be 4 into 3 into 2 into 1. It is as simple, it is just a linear. Okay, it is not having multi-dimensional. If I give you some number, you have to decrement it and you have to reach it. So let's write the code for it. Okay, so what is the code? So let's say first def fun, I'm writing one function, x is the function name, I'm passing some value, let's say 4. Okay, here what is the base condition? The base condition is once it reaches to 1, then return the value. Okay, once it reaches 1, see, it will start from here. Once it reaches 1, again return 1. Okay, so what to do? If x equal to 1, then return 1. That's it. That's it. This is the base condition. I told you already the structure, right? Structure is first will come base condition. So once it reaches 1, it will return 1. If it does not reaching, if it is not reaching, then you would do return x, that is value, into the same recursive call x minus 1. Okay, it is very interesting. It is tail recursion. Tail recursion means nothing is there after the tail. Okay, if I print it, I have to print it here so that it is returning in the main function. If I print it, answer is 24. How answer is 24? Exactly, watch it. So first time what is happening? First time I am placing fun of 4. Okay, in fun of 4 what is happening? In fun of 4 what is happening? It is not equal to 1. X is not equal to 1. X is equal to 4. So what will happen? 4 into fun of 3. Again, do I know fun of 3? No, I don't know fun of 3. So what it will do? 3 into fun of 2. Again, 2 into fun of 1. Now, once it reaches to 1, it is a base condition, that is x equal to 1. So it will return 1. Return 1 to where? To the last function. So this whole thing will be 1. So answer is 2 into 1 is 1. So again this whole answer will be returned back, as because you are returning each and every function call. Whatever function call you are doing, once you get the answer, you return it back. So I have got the answer 2 into 1. Answer is 2. 3 into 2. So here 3 into 2 is 6. Answer is 6. 4 6 are 24. Answer is 24 here. Okay, this is how you found out the 24 answer. Same goes for 25. It will just do into 5. Alright, this is how one dimensional, this is linear, this is linear in nature. Okay, just calling one by one function and it is returning back. Alright, so I hope you have understood this question. Next comes Fibonacci series. Fibonacci series. Fibonacci series question is one of my favorite, as because it is not just a mathematical formula, but it tells you about the universe. Whole everything in the universe follow almost have some pattern. That is, pattern is nothing but Fibonacci series. If I have to show you, just observe this Fibonacci series in nature. So if you look at this, all the pattern, with starting from sunflower to universe to everything, it consists a pattern that is followed by Fibonacci series. So it is not just a number, it is a magical formula. Alright, so how should we do? Let's look at it. I hope you are understanding till here. Okay, so Fibonacci series, what it will do is, I'm sure you know it, 0 1 we will start and it will just keep adding it. So the next number is 1, the next number is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 8 is 5 plus 3 is 8. So if you ask me fifth term, it is 0 0 1 2 3 4 5. Fifth term is 5. Okay, fifth term is 5. It starts from 0. It's the term. Okay, if you tell 5, it will be 5 answer. All right, how? Let's see that. Okay, let's see that. First I will do what? first I will write the code and then I will try to explain you. So first what I'm writing, if x value is 0 or 1, then what I'll do, I will return that value itself because it is same. So if x is less than or equal to 1, means x can be 0 or x can be 1, then return the itself means return x means whatever the value it is, you return that value. If not, you return fun of x minus 1 plus fun of x minus 2. This time it is not a linear anymore, it is a 2-dimension. Okay, it is not 2-dimension, again multi-dimension it is. From each and every function it will be calling 2 more functions. Okay, let us see first how it happens. So first I am taking fun of 4. Understand the understand the structure is very important. So fun of 4 I am calling. In fun of 4 you can see x is not equal to less than equal to 1. So what it will do, it will call 2 more functions, that is fun of 3 and fun of 2, and you have to plus it. Okay, x minus 1 is 4 minus 1 is 3, 4 minus 2 is 2. Alright, next is fun of 2 plus fun of 1. Here fun of 1 plus fun of 0. I hope you are understanding this. Okay, next comes fun of 1 plus fun of 0, and here fun of 1 is final. Yes, because it will not go beyond that 1 and 0. Alright, if it is 1, return 1. If it is 0, return 0. So 1 plus 0 is 1. Again it will return 1 here. It will return 1. So 1 plus 1 is 2. So this side 1, this side 0. 0 plus 1 is 1. 2 plus 1 is 2. So answer is 2 plus 1 is 3. So answer is 3. The fourth term is 3. Similarly, if you write 5, answer would be 5. Okay. Now the most important thing here is, some people would assume that, okay sir, both the functions are being called at the same time, it is parallelly going. No, the answer is false. Why? Because understand this, whenever you are running a recursive function, it is always at a time it will run one function. What does it mean? It means that if you are calling this one, the first function is this. If you see, the first function is this, after the second function is this. So until and unless it gets the answer, it will not go to the second function. Okay, that is its nature. In simple words, thread. At a time only one thread will be running. What is thread? Thread is the single unit of process. What is process? Process is program under execution. Okay, so thread is the smallest or single unit of process. So basically at one time only one thing will run. So once you call this the flow, understand the flow where it is running. So it is flowing through the here, and again it goes here, again it goes here. Once it finds out the answer, it will come back, and then this side, right side, then it will find out the answer, and then again it will go this side. Once it finds out this, then right side, left side, right, and then it returns the answer as 3. So this is the flow of the program. Flow of the program is very, very important. Many people misses it. Alright, so this is a very classic example to understand Fibonacci series. Alright, I hope you have understood this particular program. Next comes third one, that is my favorite, that is Tower of Hanoi. Tower of Hanoi. Understand this very well. Put your 100% attention, otherwise you won't understand. Okay, so look at the complexity of the program and how easily we can solve this program. Just look at it. So let's see Tower of Hanoi first. What is Tower of Hanoi? 3 towers will be there, and then your task is to bring all these disks here to here. The only thing is, it should be the size of the minimum disks should be above all, and the largest one should be in the bottom. Okay, the smallest one should be above, largest one should be below. Example, see, if I keep it here and if I try to keep the larger one here, it is not possible. That is the rule here. Alright, so what we need to do, we need to bring all this here to the destination. So this is called source, helper and destination. Now the main restriction is, what you have to do is, you have to make this in this minimum moves. You can't take forever to do. You can't take infinite time, infinite moves. You have to do it in minimum moves. So what we'll do is, I will try to bring this here. Why? So that this one should be here, and this one I can keep it here, and I will keep it here, this, and this. So this is how I have done it, minimum 7. So till 3 it is very simple. Okay, now let's go for 4. What I'll do, I'll keep it here. Why I'm keeping here? There's a reason, so that the second last one I can keep in the middle, and I'll be putting it here so that the last one is free for the last tower, and I can move it to, let's say, here, so that I can bring it here, and again it goes here like this. It is very simple. But the problem comes when it is more than, let's say, 7, 8 or 20. Imagine 20 discs are there. It is very difficult for our human brain, because imagine here how many moves are required. 255 moves you need to make it correct. That is humanly, I'm not sure is it possible or not, but yeah, it is surely time taking and energy. It will take a lot of energy. Alright, so what we'll do is we'll try to make a program that runs this particular program. So what we'll do is, whenever this kind of program comes, you go in the basic. What is the basic? What is the least one? So we'll try to find a algorithm for it. So let's say this is source, this is helper, this is destination. Source is where it starts from, helper is middle one, and destination is where you have to reach. Imagine there is only one disk, n equal to 1. N equal to 1 means there is only one disk. If there is only one disk, what you would do? What would you do? This is the base condition, means this is the last step that you need to follow. So base condition would be, base condition, this is the first condition. Okay, base condition would be move n that is one first disk from source to destination. This is the step that is directly you would bring from here to here. Okay, without any confusion. This is the first step. Now second step, imagine it is not 1 but it is 2 tower this time. Source, helper and destination. 2 towers are there. This time what would you do? This time what would you do is basic simple example that if n is equal to 2 means 2 towers are there. All the n minus 1. What do you mean by n minus 1? If there are 2 towers, n minus 2 minus 1 is 1. So all these towers, all this disk, you need to make it here. Why? So that I can move the last one, that is remaining one disk, to the last one. This is the basic fundamental algorithm for this. So what would I do? I would call the tower of Hanoi function, and I would move n minus 1 from source to helper using destination, because I want to move all n minus 1 from here to here using this destination, as because this tower is free, right? So I want to move this one to here and using destination. Why I'm using destination? Because I'm just not taking as only one. Here it can be 10 disks. Imagine 10 disks are there. So what I would do, I would move all those 9 disks from here to here in the middle, that is helper, with the help of destination. So that time I would need the destination, so that I can bring all the 9 towers here, so that the last one should go here. Okay, so this is the second algorithm that you need to use. N minus 1, all the n minus 1 disks, leaving the last one, bring from source to helper using destination. Okay, after that what is remaining? After that last one is remaining, right? So what you do again, move n from source to destination. So this is the step. After moving all n minus 1, this is the last step, that move n from source to destination. After that, one more thing is remaining. What is that? Move all the n minus 1 from helper to destination again. Okay, this is left, right? So one more step is remaining. What is the 3-step process? So move all the n minus 1 from helper to destination using source. This time source is the empty one, so you need to bring from helper to destination. I hope you have understood these three algorithms, 3 lines of algorithms. So first algorithm is move n from S to D. This is the base condition. If you are last one, move from source to destination. If it is not last, then move all n minus 1 from source to helper using destination. Okay, after moving, move the last one n from source to destination, and then after moving from source to destination, the last one is move all n minus 1 from helper to destination using source. Okay, these 3 lines are enough to solve you a problem. So what I'll do is I'll change this. So this time I need to send few more things. What are the few more things? First is number of towers. Number of towers is 3. I am passing source, I am passing helper, and I am passing destination. Okay, source, source, helper and destination as a variable. So x and s, h and d, these are the variable that I'm catching. Okay, so the first condition, what is the base condition? The base condition is if n equal to x equal to 1, means only 1 is remaining. If only 1 is remaining, what would you do? Print move x from S to destination. Okay, understand this, what are variables and what are static variables and what are static things. These are static, these are variable. Okay, this would change. Now after doing this, as because it is the last disk, what you do, would you do? Return. If this is the base condition, right, you should return back. If it is not the last case, what would you do? The second condition is move all the, again you are calling, move all the n minus 1 from source to helper using destination. This is a very important, source to helper using destination. After that, again what you do? You move that, print move x from source to destination, as it is the last one is remaining. So would you would do this again, last remaining is n minus 1 from helper to destination using source. So what would you do again? X minus 1, again you move from helper to destination using source. That's it. 3 lines. You just need to understand 3 lines. Okay, how many numbers are given? Don't care about it, just care about the 2 basic things. If you can do 2, you can do 100 also. Alright, so let's check it out. The answer should be something like this. 7 steps are there. So you can check it out. 7 steps will be there for 3 moves. Okay, if it is 5, then it would be how many moves? You can just check it out. So everything it will calculate and it will give. It is not less than a magic, you know, it is not less than a magic. If you try to understand this, how it is working, it will be very difficult. But how would you understand? You have to understand in this way. If 1 disk is remaining, how would you move? If 2 disks are remaining, how would you move? That's it. Everything will be taken care of itself. So this is like a magic to me. This is like another world which is opening, a world of mathematics. Okay, so I am falling in love with maths day by day, as because maths amazes us. Maths is so beautiful. All right, so I hope you have understood this. If you have not understood, just go through it again so that it becomes more clear. If you want more videos, just let me know so that I can make more videos of it. And that's it. I hope you have understood about recursion, and keep learning, keep moving. Don't forget to subscribe. That's it. Thank you.